Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 4 of the February daily LeetCode challenge, and once again we have a easy question, and this is the fourth easy question in a row. And as similar to like what I've shown you previously, again the solution that I will be showing you is beating 100% of the test cases for both Python and Java. Okay, I will be showing you both Python and Java in this video. As you can see, like I'm projecting my screen now. This is the Java solution. Okay, it's beating 100% of test cases, and time complexity it is beating 19% of test cases. Okay, and similarly if you see the Python solution, it is beating 100% of test cases, and in terms of memory it is beating 9% of test cases. Okay, so yep, these are the solutions that I will be showing you, both Python and Java. So please be with me. I'm sure that after watching this video you will not have any doubts left for this kind of questions. Okay, again, just a reminder for those who are new, this is the fourth day of the February daily LeetCode challenge. Prior to this we have seen four such questions, that is including today we have seen four questions, and for all of those I have shown you solutions which are beating 100% of the test cases for both Python and Java. So my request will be, if you have not seen those videos, please go and check that out. There are some really good questions. They were easy questions, but still I have, see, there is a lot to explore in that. So my suggestion to will you please go and check that out. Maybe then you can come to this video. Again, once again, it's question 1800. Here, if you just, I'm like trying to, make a path from what you have seen yesterday to what we are seeing today. Okay. See here in this question, like I'm not showing the question till now, but just understand this part that maybe you can pause and read. But yeah, just I'm trying to create a link between yesterday's question and today's question. Okay, in this question, it's exactly same as that of the yesterday's question. Only difference is that here they're asking about sum. Okay, if you see previously yesterday's question, see this is, as you can see here, it is the day fourth question. Okay, now if I go to day three question, if you see here is the day three question, right? In the day three question, if you see it is J, they were just asking about the length. Okay, they're just asking about the length. Okay, if you see my solution, this is the solution that I showed you for yesterday. Again, like this is beating 100% of test cases. Even yesterday, I'm showing about, right? Now, in this question, I'll like explain. I've worked a lot to explain every aspect of this question. I've included multiple print statements, and I've tried my best to make you understand every aspect of this question. Okay. Now, exactly same logic we are going to apply today also. For that reason, my request to you will be, maybe like I can give the link for this video in the comment section. Please go and see a day three video. Okay. It is very good question, and exactly if I solved yesterday's question, today's question you can solve within a minute, and you will be able to beat 100% of the test cases. That is the guarantee that I am giving you. So currently what I'm showing you is the solution for day three. So exactly the same thing. If you see here, we are having length. Okay, increasing subarray length. Okay, here we are talking about length. Now if you come to today's video, here we are talking about increasing subarray sum. Okay, the only difference is here it is sum, and here it was array. Okay, that is the only difference. Here they were asking the length of the subarray, which is strictly increasing, the longest subarray length, which is strictly increasing. Here we are having exactly same thing, but in this case they're asking about the maximum sum of a strictly increasing survey. Okay, only difference is sum, and the last question it was length. Okay, exactly same. Here only twist is that they were also asking you about the decreasing subarray, but in today's question we do not have any such thing about decreasing subarray. So to be honest, this question is going to be easier than yesterday's question. Okay, just to be like I'm just trying to create a link between what you have seen yesterday and what we are going to see today. Okay, so my request to you, please go and check this out. Here I have like I am confident that what I've shown will be enough for you. So in this case, like I've shown you each step, I've shown you the outputs and all that. Okay, my request to you, please go and check this video out. After seeing this video, I'm damn sure that you will not require any other explanation. By default, you will be able to write a code which will be beating 100% of the test cases for today. Okay, I'm talking about day 4. Now coming to today's question, see this case. It is 1800 maximum ascending subarray length. Okay, right. So let me quickly zoom in. Let us begin. Yeah, so if you can see, like we are given an input array. Before, let us just see the constraint also. So the input that you're going to get, okay, it's going to be of the length of 100. Okay, at max it is going to be in the length of 100, 1 to 100. Similarly, each of the values in the input is going to be in the range of 1 to 100. Okay, now yeah, now let us begin the question. Given an array of positive integers nums, return the maximum possible sum of an ascending subarray in nums. Okay. Now, what is the ascending subarray? See, that's why I'm mentioning. If you have seen yesterday's question, this will be nothing at all. Remember, ascending subarray is not a technical term as such. It's something which they are trying to invent. Okay. I have not seen this term being used anywhere else. It's something they are inventing. For that reason, if you see, they have also given the explanation of this. Okay. They are also explaining what it means. Okay. So it's the something that LeetCode is using on its own, and they have also given the explanation for that. Okay, for that reason. Okay, so now if let us say you don't know this term, what you will do, you will try to understand it by through this. Okay, but since I am suggesting you to try yesterday's question, so you will be able to understand now that increasing subarray length, that is, see, this ascending subarray basically means that strictly increasing subarray. Okay, ascending subarray means strictly increasing subarray. What it means exactly? Strictly increasing subarray means, let us say I am at element number I. Okay, let me take the example like this. Okay. See, from 10 we are going to 20, that is from you were at 10, now you're going to 20, so it's basically increasing. So idea here, it is strictly increasing. Okay, that is the basic idea. Now if you see here one case, let me go to yesterday's question. See here what was happening. No, here two elements were common. Okay, here the two elements were same. In this case it was neither strictly increasing nor strictly decreasing. Okay, because they were same. Okay, but in this case they're very clearly mentioning that it has to be strictly increasing. For that reason, only if it is like you are an ith element and you are going to I plus 1th element, only if it is greater than the current element, only then you can say that it is strictly increasing. Okay, in this case if you see 10, 20, 30, they are strictly increasing. Okay, from 30 to 5 when we come, it means it is decreasing. Okay, it's basically decreasing. From 30 we are going below, okay, which is 5, right? Again from 5 to 10 to 50, it is again strictly increasing. Okay, so only the ones which are strictly increasing, you have to consider that part. Okay, for example these three, and for example these three. Okay, so these are the two subarrays which you can consider, and among them whichever is the having the highest sum, that you have to take. Okay, I will again repeat the question. Given an array of positive integer nums, return the maximum possible sum of an ascending subarray in nums. I hope you are clear with what is a subarray, because see, again, like in yesterday's question, I have explained in detail what is the difference between a subarray and a subsequence. Okay, so I'm expecting that you will not be having any more doubts in this. Okay, please go and check that video out. I explain everything in detail. For that reason, I'm going a bit hurry into this video. Okay, right. Again, they are giving you the definition of a subarray. It's a contiguous sequence of number scenario, right? Now this is, I'm not going through this because I have already explained you the meaning of ascending subarray. It basically means strictly increasing subarray. Okay, what is strictly increasing subarray? Everything is explained in detail in yesterday's question, right? Now coming to today's question, see this part. We have only two possibilities. Okay, 10, 20, 30. Okay, here the sum is going to be 60. Similarly here 50, sorry, 5, 10, 50. Here the sum is going to be 65. So we'll take this one because it is giving us a higher sum, because we have written ultimately maximum, right? Maximum possible sum. For that reason, this particular subarray is going to give us the maximum possible sum. Okay, there are only two possible subarrays, 5, 10, 50 and 10, 20, 30, because only they are strictly increasing, right? Now coming to example number 2, in this case everything is strictly increasing. Okay, that is the whole subarray. If you talk about the whole input, it is a subarray in itself first of all, and or whole, like every element is part of a strictly increasing array. So you have to take sum of the whole array. Okay, one important aspect that I did not tell you is that, see this part. This is something that I did not tell you, but it is also important. See this case. Note that a subarray of size 1 is also ascending. Like that is, let us say, okay, let me type it and show it to you. See, I hope my screen is visible. See this case. Let us say we are having something like this. Okay, 3, comma 2, comma 1. In this case, if you see, everything is strictly decreasing. Okay, from 3 we are going to 2 and we are going to 1. Okay, there is basically no subarray of length greater than 1. Okay, in this case, which is strictly increasing, right? Do you agree with me? I will again repeat slowly. In this example, there is no subarray which is strictly increasing, which is having a length greater than 1. Okay, so if you see, we are having just subarrays of length 1. Above 1 we cannot go because it is not possible, right? So only subarray possible which is satisfying this condition is of length 1. Okay, that's why they have mentioned in this case. Note that a subarray of size 1 is also ascending. So in this case, if you see, the answer is going to be the maximum value. Okay, the maximum value in this whole. Okay, so the answer in this case is going to be 3, because 3 is the biggest element in this, and each subarray in this case that can be formed is of size 1. Okay, because more than one, that is a subarray of size more than 1 is not possible here, because that will not be satisfying this condition. Okay, that will not be satisfying this condition. So in this case, the answer is going to be 3, because 3 is the highest element in this. Okay, that is something which is very important. So know this part also. Okay. Yep. Now we were at example 2, and yeah, final example 3. Okay, again go through this. See, I will again show you 12 and 17. It is the, okay, it is a strictly increasing subarray, right? After that, because from 17 to 50 it is decreasing, so we have to stop. So 12 and 17 is one of the strictly increasing subarrays. After that, see, okay, 15 is not possible. From 17 to 15 it is not possible. From 15 to 13 it is not possible. Then 13 to 10 again it is not possible. But again from here 10, 11, 12. Okay, again this is something which is strictly increasing, so this is also possibility. So if you see, there are two possibilities, 12 to 17 or 10, 11 and 12. Okay, now if you see, the answer is going to be this, because you have written the maximum sum of a strictly increasing subarray. Okay, so in this case 33 is going to be the answer, and this is the subarray from which we are getting that answer. Okay, I explained every constraint here, and again let us go through the solution. I will show you both Java and Python solution. And I'm expecting that when you are coming, by the time you are coming to this part of the video, you would have already checked out yesterday's video, because every logic building activity that I have shown here is needed in current question. Okay, please go through and check it out. Everything that you need for today's video is explained in yesterday's video. Okay, now, yep, let us begin now. See, again, same thing. This is what I have shown you previously also. If you see in yesterday's video, we had increasing subarray length. Okay. In this current video, we are having increasing subarray sum. Okay, that is the only difference. Here we are calculating the sum. Previously, we are calculating the length. Okay. This is the increasing subarray sum, right? I'm calculating the length of the given input. Then I'm starting my answer with 0. Okay, nums of 0. If you see in yesterday's video, we are starting with 1, because the smallest length is going to be 1 in this case. Okay. But here we have to start with nums of 0, right? Now, see, everything is same. Okay, everything is same. See, I'm going through each index from 1 to n minus 1. Okay, I'm skipping the 0th index. You will ask me why. See, idea here is for every I, I'm going to compare it with its previous element. Okay, so for every I, it will be compared with nums of I minus 1. Okay, nums of I will be compared with nums of I minus 1. For that reason, I'm starting with index 1 and I'm going till n minus 1. Right? What I'm doing, see, if it is strictly increasing, okay, if the current element is strictly greater than its previous element, so in that case we have a condition. Okay, what are the other cases? When the current element is smaller than the previous element, or when the current element is equal to its previous element. Okay, there are two other cases. Each one of them will be part of this else. Okay, each one of them will be part of this else condition. Okay, let us go through each of them once. So let us see the case number one. Case number one is when current element is strictly greater than the previous element. In this case, what we have to do, remember each of these conditions, whatever I'm talking about, everything I have explained in detail in yesterday's video. So if you see exact same thing, okay, exact same thing, maybe you can copy paste this solution itself, just make some minor changes and you can get the solution. Okay, as simple as that. Now, what is happening if this is 0? Okay, if this is 0, what that means? That means that previously the elements that we have seen, they were not forming a increasing subarray. For that reason, this was 0. Okay, if it is 0, that means previous the element that we have seen was not part of a increasing subarray. Okay, now for what we have to do, we have to add the current element and the previous element to this. Okay, current element and previous element will be added to this. Okay, if let us say this is not 0, in that case what we have to do, we'll have to just add the current element. Okay, why I'm doing so? See, again, this exact same thing I have explained in yesterday's video also. If you see, I've taken this example and I've shown you why we are starting from 0, and then from 0 it will directly go to 2, and from after 2 it will go to 1. It will be plus 1. Okay, 0 to 2 it will be going, after 2 it will be just a plus 1. Similarly, in today's question also, from 0 it will directly go to sum of two numbers, and from there on it will just be a number, sum of a single number. Okay, so if you're not clear with this part, I will again recommend, please pause this video, go and see yesterday's video out, and then you can come back. Okay, because see, ultimately you are going to like learn a solution which is beating every other solution in LeetCode, right? So please pay some time, please pay some attention, and I'm sure you will be able to learn everything. Okay, yep. So if it is 0, what we have to do, you have to take the sum of the current element and the previous element. If it is not 0, what we have to do, you have to only take the sum of the current element. Logic here is, if it is 0, basically see, it's a pair, right? Each element of the pair should be taken into account for the sum. Okay, when it is non-zero, that means even the last element was a part of a strictly increasing subarray, so that the sum for that is already taken, so we have to only take the sum of the current element. Okay, okay, I will again write it in show you, because I don't want to leave you in a very clumsy state. See, let us say 1 2 and 3. Okay, 1 2 and 3, and this particular value is going to be 0 initially. Okay, yep, let me do it for you. Okay, now what is happening? See, I am at 2. Okay, I'm starting with 2. So 2 is greater than 1. Okay, so it is part of a strictly increasing subarray. So what we have to do, from 0, basically it will be going to sum of two numbers. Okay, what are those two numbers? It will going to 2 plus 1. Okay, by 2 plus 1, see, because I'm this is the first time I'm comparing the two numbers. So because this one is not part of the sum till now. Okay, this particular one is not part of the sum. So when I'm comparing with 2, we have to take into account the one also. Okay, that is the basic idea. But when I'm comparing 2 and 3, see, now one is done. Okay, index number 1 is done. Now I'm going to index number 2. So when I'm going to index number 2, what I have to do, I have to compare it with index number, the previous index. So 3 and 2 will be compared together. Now since 2 is again already taken into account in this, okay, see, 2 is already part of this. Okay, from 0 this value got changed to this. Okay, so 2 is already part of this sum. So what we have to do, we have to only add 3 now. Okay, so from here basically it will be going to, see, 2 plus 1 and then plus 3. Okay, it will going to, so only the plus 3 will be done here. Okay, 2 is already part of the sum, so only we have to do plus 3. Okay, that is the basic idea. That's why if you see, when it is 0, you have to take both the sum of both the numbers. When it is non-zero, you have to only add the current number. Okay, as simple as that. Now since after doing all this, what you have to do, whatever is the value of this, okay, it could be the possible answer. Okay, for that reason we have to compare it with the existing answer. Okay, whichever is the maximum value that you have to append into the answer. Okay, now there are two other cases. Case number one is when current element is strictly greater than previous element. There are two other cases. What are they? Current element is strictly smaller than previous element, or current element is equal to previous element. Okay. In either of these cases, is the subarray that is forming is not a strictly increasing subarray. Okay. So this particular condition is not getting applied. For that reason, the link is breaking here. Okay. For that reason, increasing subarray sum will be restored to 0. But remember, there is a catch here. This is something that is not present in yesterday's video. Okay. So there is a catch here. See, since a single element is also a possible subarray, okay, possible ascending subarray. So though we have made this particular value equal to 0, but still the current element could be a very big element, and that could be part of the answer. Okay, for that reason, even though we have made this as 0, but still we will compare this element with the answer, and if it is very high, very huge element, then this could be possible answer, and we'll update it here. Okay, as simple as that. So this will keep continuing. So I've shown you two cases. Case number 1, case number 2 and 3 will be here. Okay, but here there is a catch, though we are making this as 0, because see what is happening, current element is smaller than or equal to previous element. For that reason, the subarray that is forming is not a strictly increasing subarray. So this is made as 0. But since the element could be bigger one, so we are just comparing the here. If you see, we are comparing the sum, okay, subarray sum. But here we are only comparing the element, okay, because even a single element is a subarray which is strictly increasing. Okay, as simple as that, right? So this logic we're applying here, and we are only comparing the single element, right? Now, after doing all these things, we are just returning the maximum answer. Okay, as simple as that. If you see, we are starting with nums of 0, and we are finally returning the answer. Okay. Now let me comment it out and let me show you the submission code. Okay. Then we'll go to the Python solution. So as you can see, this is clearing all the test cases. I have already segmented this solution, and the proof here is it is, as you can see, beating all the 100% of the test cases. Okay, this was the Python solution. Let us go to Java now. This is the Java solution. You can see even this is beating 100% of test cases. You see the code exactly same code. See what I'm trying is I'm even keeping the variable name same so that you don't get any confusion of what is happening. Okay, see this variable I'm initializing this. Okay, rest all, if you see, it's just same. Okay, it's just a difference of syntax. Okay, there is nothing to explain as such. Okay, everything is same. The loop is starting from 1 and going till n-1, and everything else is same. The only difference here is, as I mentioned in the yesterday's video also, the only difference that is coming is here. If you see in Python, we were directly calculating using the max function. Here the only difference is you'll have to use the math class to do the max. Okay, so what is max? Basically, max is basically a static function present in the math class. Okay, remember, this is something that can be asked in the interview also. So why you are writing math dot max? Why you just can't write max? Okay, can we just delete this part? Why we are writing math dot max? Can we remove math dot? Okay, that is not possible because max is a static function. In order to use a static function, you always have to call it with the class name. Okay, so in this case, we have to do math dot max only. Okay, some people will ask, can I write like this? Okay, math dot max. Can I import max directly? And can I remove this part? Okay, can I remove this part then? Okay, it is not possible because, as I mentioned, max is a static function. Okay, it has to be with a class name. Okay, otherwise you will get errors. Okay, that is the only difference compared to Python and Java. Okay, other than that, everything is same. Okay, yep. As you can see, this is the code. I will give this codes in the comment section. You can go through them. Okay, you don't have to you know keep running the video to see this code. Just pause the video. This solutions are there in the comment section. Go and check them out. So yeah, that was all for today's video. And yep, if you talk about the time complexity, it is O of n. Okay, because if you see what we are doing, just a single loop we are using, and yeah, there is nothing else we are doing. If you talk about the space complexity, it is going to be O of constant. That is O of 1. Why? If you see whatever variables that we are using, okay, one or two variables we are using, all of them are not dependent on, okay, none of them are dependent on n. Okay, for that reason they are constant space complexity. Okay, so O of n time complexity, O of 1 space complexity, right? Yep, and that was all for today's video. And yep, from last 4 days, I am feeling very good that I am showing you solutions which are beating 100% of the test cases. I hope you are getting some confidence through this. You are getting some extra learning from this, because normally what happens, whenever it is easy question, people will simply they will easily they can solve and they can go off. Okay, but remember, always remember, you have to prepare for interview. So if this question comes in interview, can you guarantee that okay you will be selected? Can you guarantee that? Okay, can you write this on a paper and give it to yourself? That is not possible. Okay, that's why I'm saying whenever it is easy question, that competition will be more difficult, because everyone can do it. Okay, for that reason the competition will be even more difficult. Sometimes in hard question, what happens, many people won't be able to solve it, so your chance will be higher if you're able to solve it. But in easy question, since everyone can solve it, your chances will be very less. So what you have to do, there are two things that you can do. Point number one, write a solution which is beating 100% of the solutions. Because many times when the question is easy, they will be seeing how your solution is performing. Okay, how fast you are able to solve it, at the same time how fast your solution is. Okay, if it is beating 100% of the test cases in terms of time, then yes, your solution will be among the highlights. That is point number one. Second point is that if you are in a face-to-face interview, okay, in a face-to-face interview, the main thing is your code will be watched. Okay, not about your space or time complexity. Your code will be watched. Okay, so if you're using any inbuilt function to do the code, please do not use it. Okay, please do not use it, because if you're not able to code it without an inbuilt function, then you will be facing some negative marks, because in easy question you are expected to solve everything on your own without using any inbuilt function. That is the second point that I want to mention. Okay, I mentioned 2 points. First point is your solution should be beating 100% of the people other solutions. Second point is that you have to solve without using any inbuilt function. In my solution also, I have not used any inbuilt function, and I recommend you also please do not use them, because so see in LeetCode, no, what happens, they sometimes give very generic solutions, very easy solutions. Okay, very easy questions, I mean. But yeah, the logic is very okay. Okay, inbuilt function you can do it very easily, but without inbuilt function it will be slightly lengthy and longer. Okay, so please be useful. Please be please be mindful of the fact that you should know everything. You should not be dependent on inbuilt functions for a long time. Okay, you should know the alternatives also. Okay, So yeah, friend, that was all for this video. I am feeling really happy that yeah, I am showing you a solution which I'm beating 100% test cases from last 4 day. Okay. So if you like my efforts, if you want to be part of this community, if you want some motivation to code every day, please join our community. Please subscribe to our channel. This really gives us a lot of motivation to continue further. Our aim is that, because see, not everyone can buy costly courses to learn coding. My aim is that I provide you quality content through YouTube channel so that everyone can see it for free. Okay. So but that will only possible if, okay, my visibility increases, which will only happen if you subscribe. So please subscribe and leave your comments so that I can improve further. If you want me to improve further, please do let me know what I can do more. I am uploading English and Hindi videos every day now, so please let me know if you have anything to say with which I can improve further. So yeah, that was all for today's video. See you tomorrow. Thanks a lot.